KASS Engineering, and today I'm going to give a quick overview of our capstone project before I hand it over to the specifics. So as a project introduction, what we're doing is we're revitalizing this block right here between 4th and 3rd and Cardinal and Brandeis. What they plan to do is to implement a two-phase sort of construction project, with the second phase being the apartment complex. It's a project we haven't touched on very much. Our focus is on phase 1, which is divided between two buildings, a hotel that's about 10 stories tall and an office/retail space that's about 4 stories tall with 2 layers of underground parking. Now, we need this underground parking because the site's very restrictive in what it can provide for everyone to bring their cars and park in the actual area. So we had to provide approximately 100 spots per floor in our parking structure. Now, the retail space is a bit larger than the actual office space, where it's about 14 feet tall, and then every other floor is pretty uniform after that. And of course, our focus is on that retail and office space as the other group prepared for the hotel space. So as we get into this, we're going to take a complete look at the transportation. It's a bit brief of an introduction, but our transportation team is going to come up and give us a quick overview of what's going on transportation-wise for this project. So let's take a look at that. Just hand me the slides if you guys want to focus on. We lost connection. I'll just handle the slideshow, I guess. Do we want to just try your computer? Okay, so our transportation team, headed by Emily Netherton, our project lead for transportation.
Hi, my name is Austin Robinson. I'm part of the transportation team here at KASS Engineering. And so I'm just going to go through a little overview of the site, just to add on to what Jacob presented first. So basically here we got a 3.47 acre site, currently zoned C2 commercial, which is just heavy commercial. You can see up here some of the mock concept drawings that have been created for this site, just to further illustrate what all is going to be there. As far as the transportation goes, there are currently 4 signals shown in the drawing on the left. These are at the 4 corners of the site, and per this construction, Brandeis Avenue down at the bottom is supposed to be completely removed, and those signals will be changed. I'll let the other group talk about it because they kind of have more information on that. But yeah, that's pretty much how the site is now. There's going to be 2 proposed entrances, one on West Cardinal and one along 3rd Street. So that's kind of the general overview of the site as it sits.
Right here we have our parking garage. It's going to be a 2-story garage with 212 parking spaces. We're going to have a double helix pattern going down to ramp down to the 2nd level of the parking garage, and there's going to be parking all along that ramp. Our parking is just under the Target/office building, office complex, and it's going to, yeah, it's going to be right there. Let's go. For our, oh, that's not my slide. Oops. All right. Well, I outdid the slides last night. I'm sorry about that. But we're gonna have, you know what? Yeah, just go ahead. Because those aren't my slides up there.
Okay, so now on to the design proposals. So the other group had 2nd and 3rd Street 2-wing. So for all 3 of our designs, we have cut off 2nd Street and then made 3rd Street 2 ways, and then everything above Cardinal is how it is existing with a 1-way pair. So our first alternative is a roundabout at Brook Street, and everywhere else a single lane with a bike lane and a parking lane. except for in between second and third, it is a dual lane, just because there is so much traffic that was rerouted from second that got put onto third and Cardinal. So that is our first alternative. This worked okay, again, third and Cardinal, with all the added traffic, it didn't do so well. So our next one, we decided to try roundabouts at every single intersection, and this also included at First and Cardinal, which currently does not have a signal at, it is unsignalized. And it was all single lanes all throughout, and then again, Third and Cardinal was the issue. So we decided with a third alternative, and that was, we kept the dual lane that's in between second and third, double lane roundabouts all the way throughout. And then again, this worked a lot better compared to the other two alternatives. So yeah, our main focus was going up 3rd Street. We had like 613 turning right. And then at 2nd and Cardinal, we had 631 turning left. So that was our main focus with the designing right there on why we did a dual lane. And that one worked the best. So that is the one we would probably look forward towards more. But it does need more analyzation through VISM or other programs to model it a little better further. So that is transportation, and then we're going to hand it off to structural.
I think your team's been updated. When's the last time you
downloaded it when so it's kind of downloaded. So it's updated,
No, I mean ours is not. I'm saying just slides. I don't think updated. Okay, hey guys, I'm Cam. I'm the structural lead for KASS Engineering here, and I just want to give a few highlights about the structures we had to design for this before we get into the specifics. So we had to design 2 structures. The top there, the steel system is our office retail building. That first floor, like Jacob said, will house a Target. It's about 14 feet tall, and then it's 3 floors of office space above that. So we decided to go with a one-way brace steel system with hinge connections. It's pretty standard for structures this size. And then we have 2 floors of parking garage that extend past the building's footprint. Underneath there, we used the floor slab of the Target is going to be the first floor of the parking garage, and then we have a standard concrete slab underneath there for the second floor. We decided to go with pre-stressed concrete underneath because the construction is going to be taking place underground, obviously. So space is a big issue, and pre-stress eliminates a lot of problems coming with trying to get post-tensioning into your concrete whenever you're pouring it and setting it up. So we decided to go with that for our beams and girders for the parking garage. And yeah, I'm gonna pass it off to Brian for the specifics on the steel.
So these are our typical plan views of the building. The one on the left shows the 2nd floor, which also includes the roof of the retail structure. The one on the right shows the typical sizing of the 3rd, 4th floors, and then also the roof structure. For the roofs, we used steel decking and open web steel joists for both the retail and above the office. The floors on the 2nd and 3rd floor and the 4th floor of the office structure was concrete and composite metal deck. After analyzing this structure using gravity loads, we then input it into RAM structural systems. So we used RAM structural systems to analyze the lateral design. The program calculated the lateral loads on it and applied it, and then went in and put the lateral braces in it. For the office and retail structure, we used L 5x5x3/8 inch braces, X bracing, and then below that in the garage we used shear walls.
So for the design of the garage, we focused with ACI design handbooks, pre-stressed members that have already been predetermined to handle specific amounts of loads. We used double T-beams for our beams, and then inverted T-beams for our girders. And then for the columns of the actual structure, we are doing cast in place columns because the actual implementation of those will be a lot simpler than casting in place columns and beams. It'll be sort of a drill, case on, and then pour process to get those in place. It'll also allow foundations to move a bit quicker because the drilling required will be sort of a hand-in-hand process for the two. To get the appropriate amount of space that was required, we extended outside of our building footprint, and we kept design relatively flexible for any sort of changes that will need to be implemented as the phase 2 design completes. And that brings into our geotechnical team with our lead, Bryn Cobbs.
So first, we'll talk about the site characteristics of the soil on the site. We went and made a representative soil column for the site. This consisted of 7 different layers of soil. The first 2 below the asphalt was made up of sand and clay fill. Below that was non-plastic silt. After that, it was just 3 different sand layers down to 60 feet and beyond that. The water table was noted to be at 27 feet below grade. This was also modified to include flood conditions later. No rock was noted in the soil. This means that the foundations will be bearing on the sand and not any rock. And also due to the location of the site, there's likely to be historical construction found buried and excavations completed.
So for our site, we are planning a top-down excavation procedure, which basically means that before we ever remove any soil from the site, we first have to install the structural support for the retaining wall of the garage. So the first step is to install the steel soldier piles, which kind of provide vertical support, and then you excavate very slowly in increments of 1 to 2 feet, and then you're installing horizontal support as you go down. So you can kind of see in this photo kind of what we're going for. And then because of the soils on this site, they're not very suitable for structures that are this large. We're going to use 2 rows of ground anchors, which will be installed during the excavation process, the final depth of the excavation will be 23 feet below grade, so we won't have any interaction with the water table. So for the garage, this requires a pretty extensive retaining wall design. So the retaining wall is going to cover the length of the garage, the entire 23 feet. As I said, there are 2 anchors that'll be installed in rows to support the soils and keep the retaining wall of the garage from kind of falling forward. So these 2 anchors were kind of designed to make sure that they wouldn't be exceeding the property line, so we won't be underneath any of the road right of way, and we also won't ideally be underneath any of the other buildings. And then those anchors will be grouted in, so there's really no chance that it'll give them an additional structural element that kind of keeps it from moving all over the place. Vertical drains will be installed beyond the retaining wall to keep water away from the parking garage. And then a false ascent wall will be constructed in front of the retaining wall so people in the garage don't have to see it.
Next, we looked at the actual foundation alternatives for this design. The first ones we considered were shallow foundations, but due to the high loads of this structure, we decided not to go with that. We also considered shallow and deep foundations. This is due to the retail structure being shorter than the rest of the office structure, but because we're also adding the parking garage underneath it, it doesn't really work out. Mat foundations were another consideration, which are another type of shallow foundation, but they are more complex to design and also more complex to construct, and all around more of a headache than it's worth. So we decided not to go with that as well.
Yeah, and then moving away from the shallow and deep foundations, we went just to deep foundations. So some of our options include jacked, driven, and vibratory piles. So you can kind of see there some of the equipment that would be required for those sort of piles, which it is pretty intensive equipment, and the dynamic effects of driving those piles is sometimes not conducive to the site. So in such an urban, like densely populated area, you don't want all of that noise and all of that construction traffic. So the two piles that we really are considering are the auger cast piles and drill displacement piles. They're pretty much the same idea. You're just drilling a hole, grouting in concrete, and then installing a structural rebar system to support it. And this would work with the parking garage design because we're already drilling holes to support the cast in place concrete columns. So those are the two foundations that we will be further calculating to make a final recommendation for the site.
It brings in our hydraulic team with Austin Robinson as our team head.
So very quickly, we were tasked with developing a couple of design alternatives to capture stormwater runoff on the site. And overall, we needed, based on our calculations, around 24,000 cubic feet of storage available. And so I'll turn it over to Axel, and he's gonna discuss the first alternative.
Our first alternative includes a green option and a traditional detention option. The first alternative is tree boxes and an underground detention basin. On the site, I have about 40 tree boxes, about 10 feet by 10 feet, and it provides a little over 2,500 cubic feet of storage. For the underground detention, there's 5 90-foot long, 96 diameter inch pipes, which provide up to 22,000 cubic feet of storage, which covers the 24,000 required. Our total cost for this one is about $1.5 million, which MSD has credits for green options, so that can offset some of that cost as well.
This is underground infiltration basin. This is a 5 diameter, 96 inch, long, around 100 feet. This is provided to storage around 25,000 feet square. This is good about the storm. If you have a lot raining, you need storage, and this is you make it to avoid the risk about the storm.
So our third option utilizes rain gardens and bioswales. Essentially, these are just small wetland areas that use native vegetation to help provide infiltration and absorption of the stormwater. And a bioswale is just a linear version of that. So on there, we project that we can put around 3 rain gardens in, which will take about 15,000 cubic feet of storage, and then 5 bioswales along the outside, as you can see up there in red. Those will be able to cover the rest of the storage, about 14,000 cubic feet. Some benefits to this option: it is a green option, as is the first two. It helps filter and recharge the water into the groundwater. That way it makes it all overall cleaner, helps eliminate some pollution. It does increase biodiversity, and it provides a habitat in these urban areas for some native plant species and some animal species. And it also allows for the controlled infiltration. It helps basically give a controlled infiltration in the groundwater without causing any flooding in the area. A couple disadvantages: it does have a high maintenance cost. It needs to be consistently maintained. So that may be one consideration when deciding which option to proceed with. It also has a required setback from any buildings, along with all the other options to use infiltration. So any utilities or building foundations, we're gonna have to plan around that if this option is chosen. Thank you, Jacob. The fourth alternative, which is kind of a more standard look at it, it's not a green option, is the use of detention ponds and underground detention basins. basically, these are just gonna be areas, the detention basins are just dry areas that will collect water during a storm. The one consideration about this is we do require 3-to-1 slopes, so that definitely is a big consideration. That way, we don't have any erosion or anything like that. A couple benefits about this option: it is the cheapest overall. As far as the detention basins go above ground, it's pretty much just excavating the area. Some disadvantages though, it can also hold a lot of water too. But some disadvantages: it's not a green option. You still need the underground detention for this site due to the slope constraints, and it's not the most aesthetically pleasing, but you will provide a cost benefit with that. A couple more considerations regarding the hydrology and the hydraulics of the site. We were able to size the stormwater runoff pipe into Louisville MSD's system. So basically what we needed was 25.4 cubic feet per second. It's a discharge rate. With using a 36-inch pipe, we were able to get a 25.9 cubic feet per second rate into the stormwater, or the storm sewers. And so that'll provide adequate discharge. We also were able to get estimations for the water supply and the wastewater supply. For the water supply, we estimated that we're gonna need around 31,000 gallons per day, and that's highly dependent on the hotel, because the hotel is gonna use the most water. Again, these are pretty variable right now, considering we don't know a lot of the uses, who's gonna be where, how many employees are gonna be in these different areas. So these are all contingent on more information based on assumptions. As far as the wastewater demand goes, we consulted with Louisville MSD's manual, exhibit 8-2 specifically. As you can see up there on the screen, it provides general estimations for different uses. And so, again, more information is going to be needed to get better estimates, because a lot of that is based on population and number of people in the building. So further coordination is going to be needed with Louisville Water Company and Louisville MSD moving further to make sure we don't overload either system, make sure the pressures are okay and everything like that. I believe that's all we have. So, Jacob?
The project is a pretty complex and large project, so I'm sure there's going to be plenty of questions that we'll need to answer. So I invite the rest of my group up here for a Q&A session in case, if we have time for that. Brandon, are we doing that today?
No, but if you wanna bring them up, so I can just point at each one. and give
Really?
But yeah, that's all we've got other than Q&A.
That's a good dry run. A couple of things that I think